Okay. So good morning everyone. So today magsa-start tayo with analysis of variance, no? And ang i-cover natin for this lecture is one-way ANOVA tsaka yung chi-square analysis, no? Okay. So let's begin with parang ano lang, no? Let's recall on the parang steps in designing an experiment. So or the different na variables and factors na kailangan natin pag-isipan when we talk about designing an experiment. So let's review response variable. So itong response variable, ito yung measurable na variable na gusto nating tingnan to determine if na-achieve ba natin yung objectives natin or not. Okay? Tapos sometimes the response variable is known as your uh, dependent variable, no? Because its results is dependent on whatever factors you choose. That is of course assuming that your factors have a significant effect on your independent variable, no? Okay? So yung factors naman is sometimes known as your independent variables because sila yung binabago mong variable such that gusto mong malaman if it has an effect on the response variable, which again I mentioned is your dependent variable. Okay? Then we have factor levels. Etong factor levels, wait lang. Wait, nag-chat. Nawala sound. Hello? Mic check. Meron na? Saglit lang. Hello, mic check. 1, 2, 3. Parang meron naman. Okay, okay. Thank you. So, sige, balik tayo ulit. Baka hindi na record, no? So, again, response variable is the independent variable. Ito yung gusto natin i-measure para masabi natin um, na-reach natin yung objective natin, no? Or at least it gives us direct information about what we are trying to study. Yung factors is the independent variables because these are the these are the variables that we are changing para gusto natin malaman yung effect niya doon sa gusto natin um, ma-observe na ano, no, na response. Tapos etong factor levels, these are the different as the name implies, no, different levels siya na ina-assign natin doon sa factors natin. So say for example, we have kunwari temperature, then depending on what we are trying to study, we can have either parang two levels lang, for example, low setting and high setting, or pwedeng we can have multiple levels like for example, low, medium high, tapos high. Okay? So it all depends on the type of experiment we are trying to do, no? Tapos treatments, these are just the combination of the different factors na na kumbaga i-arrange mo such that meron kang isang experimental run. So for example, if you have two factors, tapos let's just say for simplicity, no, that the two factors has two levels, then you will have four treatments, no? So meron kang naka-low, low si factor A, low si factor B, then you have low si factor A, high si factor B. Tapos you can have high si factor A, low si factor B, and lastly, pwedeng both high si factors A and B. Okay? So yun yung tinatawag nating treatments, no? It's just the combination or the number of ways we can arrange the number of ways we can arrange the different factors, no, to come up with a combination. Okay? So that's this treatment. As experimental unit is just yung kung um, ano yung kumbaga scope ng ano natin ng experimentation. Okay? So mostly ang experimental units natin is in terms of samples, no? So kunwari, experimental unit natin is kunwari per person, that is an experimental unit. Pero in this case, hindi naman masyadong particular tayo dito, no? Okay? So what are the types of experiment? We usually have two types, no, of experiment, at least ito, or two general types of experiment. Meron tayong tinatawag na variable screening experiment, tapos meron din tayong tinatawag na optimization or modeling experiments, no? So when we say variable screening, this is when we are unsure of which factors do affect or we are trying to figure out what factors can affect our response variable. So in this case, um, for example, ito no, you have this is the extrusion of a certain metal die. So extrusion is just a metal working process wherein meron tayong blank die or a blank a blank metal, tapos ipapasok natin, i-force through natin siya into a die, and the die contains the ano no impression uh, which we are trying to build, no. So for example, ito yung impressions na yun. Pwedeng ganito ang shape, pwedeng ganito, and you can have multiple I don't know, complicated shapes. Okay, so when we extrude metal, usually there are several factors that you want to look at if it does affect the response variable. So let's just say na ang response variable na minimeasure natin is extrudability, no. So um we can have temperature as a factor. So temperature can affect. So we are studying temperature, pwede rin time, pwede rin yung die shape. Okay, so if you have multiple factors, usually in variable screening, you have multiple factors that by your experience, you know, it can affect uh, the the response variable, and you are trying to test that hypothesis, no, kung nakaka-affect nga ba siya or not. Okay? So in this types of experiments, variable screening, usually marami kang factors pero bababa yung factor levels mo, no? Because in experimentation, when you have, lalo na if you do a full na experimentation, no? Yung yung number of experiments natin will be equal to yung factor levels raised to the power of factors. So for in this case, kunwari lang ang ginawa natin is 3 factor levels for each factor, then you will have a total of 3 raised to the power of 3. So that becomes 27 experiments, no? And say for example, you need to do replication para ma-duplicate yung para sure tayo na wala tayong mga outliers, no, or mga gross na errors. Then if you do replication, that's 27 times 2, 54. So magiging 54 total na samples and or total runs, and that may be too much for some experimenters, no. So lalo na kunwari sa thesis nyo, kunwari magti-thesis na kayo or mag-experiment kayo, usually um, 54 is too much in terms of resources and in terms of time, no? So usually kung variable screening yung type of experiment nyo, and this is ano no, you need to think about this dun sa ano nyo sa magiging final project nyo for this sem. Try to think about kung variable screening ba yung experiment nyo or is it a modeling experiment. Okay? So if it's a variable screening experiment, usually you do low number of levels pero multiple factors. So let's say for example, we just choose 2 levels, which is the minimum na ano no. So you can't have lower than 2 levels kasi kung 1 level lang siya, then you don't have any adjustments. Magiging kung 1 level lang, para siyang ano lang, uh, kumbaga magiging constant siya dun sa ano sa experiment nyo. Okay? So, gagawin natin is 2 levels, kung minimum lang, tapos you have three factors, then you have 2 to the 3 becomes 8 experiments, no? And or 8 experimental runs or 8 treatments, and therefore that is a more manageable number of data that you can gather, no? Tapos multiply it by 2, you have 16. 16 is very much manageable, no? Okay? So that's for your variable screening, but there are cases wherein you are sure that a factor affects your response variable, pero you want to know how much it affects the response variable. And in this case, mas appropriate na gumawa tayo ng optimization experiments. So optimization experiments are characterized by a low number of factors, pero you have multiple levels, no? So this is um more of ano na to, no, advanced na to. This is the response surface methodology wherein hinahanap natin yung path of steepest ascent, or in this case path of steepest descent naman ang hinahanap dito, no. Pero basically parang naghahanap tayo ng region wherein meron tayong minimum yung ano natin, yung response variable. So later on you will learn more about this, no, itong optimization techniques na to. So usually ang for experimenters, the flow is usually you start with a variable screening experiment. You want to be able to determine which um, and you can again you can apply this in your final project, no. So pwedeng ang gawin nyo is you do a variable screening experiment muna. So you screen kung ano yung factors that have a significant effect on your response variable. Then after you figured out that which factors have a significant effect, pwede nang gawan nyo ng optimization experiment yung yung mga factors na naging significant through the variable screening. Okay? So for example, dito nag-variable screening tayo, tapos we have found out na si time does not have a, what is the time is insignificant. Also the die shape is not significant as well. At tapos si temperature lang pala yung significant factor. So from this variable experiment, pwede nang i-optimize nyo yung temperature. So you can have one setting lang, or I mean sorry, one factor lang, which is the temperature, pero multiple naman yung levels na. So you can have, for example, 5 levels. So from that 5 levels, pwede mo nang gawa ng model, and usually modeling results in yung optimization ng product nyo or optimization ng process nyo. Tapos you usually end up with some form of formula, no. So it's a sort of predictive na formula to predict whether or which to predict which setting can give you the optimum value for your response variable, whether that optimum value is a the smallest value or that optimum value is the largest value, no? So it depends, no. So ito, most probably they are looking at the lowest value. So kung lowest value, you are saying na parang kunwari number of defects. So syempre kung gusto mo optimum yung process nyo, then you are minimizing the defects. So it all depends on perspective, no. So pwedeng it's either a peak yung tinitingnan mo or a valley yung tinitingnan mo. Okay? So let's go to yung first type of design muna natin, no, which is known as the chi-squared test of independence. And this is usually done to test this is a test to determine if one variable is dependent on another or not. So parang gusto natin malaman if the two are dependent on each other, no. Okay. Next, we have your completely randomized design. Sometimes it's just simply the one-way ANOVA, no. And then you have your randomized complete block design, which is similar to one-way ANOVA, but we are also looking into minimizing the variation by also studying factors that may affect the results of the experiment, but not necessarily, I don't know, but not necessarily in studies. Okay, so later if I'll show an example, you'll know the difference between randomized complete block design and completely randomized design. No? And you also have your 2 and higher factorial ANOVA. And this is when you want to compare multiple means, no? So meaning or simply put, this is when you have 2 or more factors, no, that you are varying. Then you have your 2 to the k factorial design, and this is mainly for variable screening, wherein each of the factors have only 2 levels, pero marami kang kumbaga may multiple factors ka na pwedeng i-vary. Okay, so usually when we do when we do variable screening, ito yung go-to experiment natin, yung the 2 to the k factorial experiment. Okay. Meron pang variation tong 2 to the k factorial experiment, which is known as the fractional factorial experiment. So dito, it's exactly the same as 2 to the k, pero only a portion of the entire treatment combinations will be done or will be run during the experiment. So this is because sometimes kunwari you are doing 8 na let's do 5, kunwari you're doing 5 factors, then you have 2 to the 5 gives you 32, tama ba? I think it's 32, and if you do replication, that's 64 na 64 samples. So sometimes you can't do 64. So most of the time, instead of doing the full 32 experiments, gagawin natin, or 64 with replication, gagawin natin is we only do a fraction of the factorial experiment. So we can have a design that looks like 2 to the 5 minus 1. So parang sinasabi doon is um, you are taking 5 samples pero only half of the blocks, no? So magiging 2 raised to the power of 5 minus 1 becomes 2 to the 4, which is 2 to the 6, which becomes 16, no? So which is more manageable than yung 32, no? So you essentially um, have your experiment, no? And this can be done because in some cases or in meron tayong tinatawag na ano ba term doon? The I forgot the exact term, no, pero what it's saying is um and later on ano no madadaanan naman natin siya. Pero what essentially we are saying is merong mga higher order na interactions that may be insignificant, no? So for example, yung interaction between if you have multiple factors, no, pwedeng may A, B, C, D, E kind of interaction. Posible na yung A, B, C, D interaction na yun is not significant anymore because it's a higher order na interaction, no? Usually yung mga low, yung main effects lang, kunwari main effect A, main effect B, main effect C, etc. Yun lang yun lang yung parang malaki yung magiging effect doon sa ano no sa experiment natin. And sometimes pwede rin yung two-way interaction, pero yung mga three-way pataas usually hindi siya masyadong ano no hindi siya masyadong important or impactful. So therefore um kayang-kaya nyo na i-trim down yung experiment with that assumption no, na hindi masyadong ano, parang hindi masyadong impactful yung higher or the order na experimentation. So then you have your Taguchi orthogonal experiment, which was this is a Japanese style na design and developed by ano nga yung full name ni Taguchi. Nakalimutan ko yung full name niya. Pero si Taguchi worked for a Japanese auto company. Nakalimutan ko rin kung anong Honda ba or Toyota. I think it's Toyota na. Search nga natin. Taguchi. Taguchi is Jinichi Taguchi. Yan yun. And he worked for multiple ano no multiple ano pala siya companies. Pero I remember that he worked for one of yung medyo ano no sikat na company. I forgot the name of which auto company. Pero basically si Taguchi um parang more empirical yung type of design niya, no? So it's similar to fractional factorial design wherein pipili lang siya ng certain parang treatment combinations that he knows is can have a big effect on the response variables. That's from there, doon siya nag-develop ng certain designs, no, that can be employed. Okay, so dito sa Taguchi, it's similar to your 2 to the k and 2 and higher factorial ANOVA, pero naka-trim down din siya. Only a portion is taken and only a portion is taken kasi sure sila na yun yung malaki yung chance na may effect dun sa ano sa response variable natin. Okay? So, we begin with chi-square test of independence muna. So again, this just means that we are trying to look if or we are trying to see if a certain factor is dependent on another factor, no? So for example, dito we are trying to determine if the uh, if the income level of a particular individual affects their view um, on the RH bill, no? And this is the reproductive health bill dati na medyo sikat at the time, no? So, or pwede rin sabihin mo na if the um if your stance on the reproductive health bill is affected by the income level. Okay? So, usually pagka naka-chi-square test of independence tayo, usually it's in the form of a parang frequency type of data, no? So, for example, you can lay out your data set in this manner wherein sino yung low income level that are pro RH bill. Pwede ganon. Tapos those that are medium income level na pro, tapos high income level na pro din. Tapos you can also do for the anti naman RH bill. So you have something that looks like this. So meron tayong ito, we have we have six na six na groupings. And these six groupings corresponds to different na combinations of income level and if they are pro or anti RH bill. Okay, so it's not limited to 2 by 3. We call this a contingency na table, no? So it's not limited to 2 by 3. Pwede ring 3 by 3 depending on the number of levels. Kung kunwari, meron tayong pro, anti, tapos meron pang isang level, let's say, undecided or indifferent. Pwedeng ganun. Pwedeng 3 levels tong yung column natin. Pwede rin magkaroon tayo ng fourth level, no, dito sa income. So kunwari merong low, medium, medium, tsaka high. Pwede rin 'yon. So hindi tayo limited sa contingency table na kaya natin i-produce dito sa chi-square test of independence, no. But the main important thing is that we need to produce a frequency na type of data, no. So you are trying to group your data set into which um, combination they belong to. Okay. So if it's not a frequency type of data, then you can't use chi-square test of independence. Okay. So again, you represent your data in a row by column contingency table. So in this case, this is a 2 by 3, no? So we have 2 rows and 3 columns, the contingency. So here, R stands for row, C stands for column. So let's test at 95% confidence level whether the opinions of the Filipinos on the reproductive health bill are independent of their levels of income. Okay, or independent or dependent of their levels of income. Okay, so ang hypothesis natin, again, yung null hypothesis is always the status quo, no? So ang status quo natin will be that there is no relationship between the two, no? Tapos if yun yung natin, null hypothesis, then if we negate that statement, we have our alternative hypothesis, which is saying that the opinions of Filipino and their income are dependent to each other. Okay. Next, we define the alpha. And sabi doon, we test using 95% confidence interval. We use alpha is equal to 0.05. Okay. So, ito yung manual method. So, I'll be showing this manual method, no? And I'll be showing this manual method, tapos ipapakita ko rin yung quick method, 2 quick methods to do this, no? So we solve for chi-squared, and chi-squared is just the observed minus the expected. Expected squared divided by yung expected na value. Okay? Tapos we reject the null hypothesis if yung chi-squared natin or yung calculated natin is greater than the chi-squared alpha, which is this is a right-tailed na test, no? So you are saying na if you were to draw the the frequency distribution, ang right tail natin will be yung meron tayong tinatawag na lack of fit, no? Okay? So again, I think I mentioned this from previous lecture, no, na parang yung natin, yung mga variance na distribution, yung mga chi-squared and f-test, we always do one-tailed test sa kanila, no? One-tailed, that is a right-tailed test, because the left tail signifies yung parang too much fit, which doesn't make any sense. Pero yung right tail signifies that you have a, you have a parang lack of fit. Okay? So, okay, so gagamitin natin yung formula na to para ma-compute yung chi-squared value, pero pwede ring gagamit tayo ng p-value, no? So for example, yung chi-squared calculated natin, pwede nating ikuha yung parang inverse niya, and if we take the inverse, then makikita natin yung p-value niya, and the p-value dist pala yung gagamitin natin, no? So kukunin natin yung dist, makukuha natin yung p-value niya, and from that p-value, compare natin doon sa alpha value natin. So later, papakita ko naman paano mangyayari yun. No? Okay? So, kung bakit ganito yung expected frequency, na formula is specifically because of I don't know. This can be attributed to your probability. So if you think about it, kunwari ito, if you want to get the expected probability nito, itong part na to, kunwari, which is what is the expected outcome ng low income ka tapos pro ka na ano. Okay, so it might be better if I copy this in Excel, no? So, copy natin siya. Saan ko lang yung Excel? Okay. Okay. I hope you see my screen. Zooming ko lang para mas malinaw. Okay? So ito yung expected. Ito yung observed pala. So let's do two tables, no? So we do observed. As we can do expected dito. Okay? So let's copy the format. Okay? Tapos, ito, expected to, and let's just remove this now. So expected is, say for example, we want to get the expected na value dito sa low, then we can do it in terms of probability, no? So parang, if you think about it, yung probability na meron kang low income is just equal sa yung combined probability na pro ka, or sorry, yung combined, yung probability na meron kang low income is equal, yung probability na meron kang low income and pro RH bill ka is the probability na low income ka multiplied by the probability na pro ka, no? So this is the multiplicative property of probability, tama? So if you want to take that, so parang ang pwede natin gawin is, kunin ko lang yung ano. Okay, para mas makita natin. Ito. So, kung kunin natin yung column total na to, ito muna column total. So, column total divided by grand total, that is the probability. So, ito, equals sum nito divided by the grand total, sum ng lahat. That is the probability na low income ka. Okay, tama? Kasi di ba ang probability lang naman is the number of ways na that an event can happen divided by the total number of ways. So ito yung total, ito yung number of ways that you have low income. Tapos ito yung total number of ways na pwede mangyari tong parang dito sa data set ito. Tama? Yung grand total. So ito siya 0.336. Tapos kung kukunin mo yung pro, so this is just sum ng ito divided by total sum. Tama? So this is the probability na pro ka, tapos this is the probability na pro RH bill ka. Okay? So if you want to get the probability na pro RH bill ka and at the same time low income level ka, then we just multiply these two probabilities. Okay? So if we multiply the two probabilities, ito times ito, this is the probability na pro ka and low income. Okay? Now, if we want to get the expected frequency, then we just multiply the this probability multiplied by the grand total. Tama? Parang ganyan. So this is the expected frequency natin. So why this therefore the expected frequency can be parang ganito yung formula, no? So parang column total times row total over grand total. So natanggal yung isang grand total na parang sa denominator natin kasi multiply natin by the grand total. So parang ang ang formula talaga niya is column total over grand total, which is probability of yung sa low income, tapos multiplied by row total over grand total, which is the probability na pro RH bill ka, multiplied by grand total, tapos magka-cancel out lang yung isang grand total, kaya isa lang yung grand total denominator. Okay, so let's use this formula. Tapos ang pwede natin gawin is pwede actually set up natin siya in such a way na magiging draggable yung ano natin, no? Yung equation natin. So if you do uh, sum, so we do sum nito multiplied by sum nito, itong columns natin divided by the grand total, then we should get the expected frequency for this first na cell, no, which is the intersection of the low na income level and the pro RH bill. Okay? So, if you want this to be draggable, kailangan natin isipin kung paano yung behavior na, no, or ano yung i-fix natin. So, if you do remember the dollar sign na parang method, no, wherein pagka nilagyan natin ng dollar sign yung letters, pinifix natin yung columns, pero pag nilagyan natin ng dollar sign yung numbers, then pinifix natin yung rows. Okay? So, we want to be able to drag this to the right, and siguro tagalin ko na lang muna ito, no, para mas ma-imagine nyo. So, gusto natin na kaya nating i-drag to the right yung itong array na to without it changing ng, kumbaga, hindi magbabago yung ano niya, yung yung parang arrangement niya dito. Tama? Kasi pag dinrag natin to the right siya, kunwari lang, if we drag it to the right na ganyan, mangyayari is magmo-move to the right yung column natin, which doesn't make sense, no? Kailangan kasi dito, eto nandito pa rin siya. Tama? So, the way we fix that is kailangan natin i-fix yung letters, no? So, if we do dollar sign, parang ganyan, you can do either manually place the dollar sign before the number, or pwede ring you press F4 tapos magta-toggle siya between the different na parang different ways na pwede mong ilagay yung dollar sign, no? So, I'll do ito. Okay, so that's correct na. So, multiplied by sum ng ito naman. So, dito naman, gusto natin pag dinrag natin siya to the right, magmo-move siya along with the ano, no. Pero pag dinrag natin bottom sa baba, dapat hindi magmo-move yung itong parang array na to. Okay? So, in this case, kailangan natin dollar sign yung number naman. Tama? Parang ganyan. Tapos divided by yung sa grand total, which is in this case, kailangan hindi mag-move at all to, no? Kasi this is the grand total. So we do F4, F4. So we have something that looks like this. Now notice pag dinrag ko siya ng ganyan. So let's take a sample. No? Dapat pag ito yung kinlik natin, it should be ito yung array for the column and ito yung array for the row. So if you notice, pag ni-remove ko to, no, you'll see na nakaano siya. Tama na yung array na pinili niya. Okay? So again, sobrang useful ng class, no, yung pag-place ng dollar sign para mas mapabilis yung magiging workflow nyo. Lalo na pag it involves dragging formulas, no. Okay? So, meron na tayong expected, meron din tayong may expected na tayo na outcome, tapos may observe tayo. Now, what we need to do is kailangan na lang natin i-solve yung chi-squared na calculated, no? So, to solve the chi-squared calculated, we just take this value, no? Ito siya. And bring down to. Okay? So, ito yung chi-squared equation natin, calculated. So, it's the observed minus expected. So, I just say chi-squared value. Chi-squared, and let's say chi-squared calc to. Chi-squared calc is equal to yung summation ng observed minus expected over observed. Okay? So, perhaps the easiest way to do this is to create another table, no? So pwedeng create tayo ng isa pang table dito. So let's just say ito is observed minus expected. Or observed versus expected na lang. So what we can do is equals, or ano na lang pala. Mas okay na gawin natin chi-square table to. So gawin natin is equals observed, open parenthesis, observed, which is this one, minus expected raised to the power of 2 divided by expected. So in this case, hindi natin kailangan mag $sign kasi gusto naman natin pag dinrag natin siya, nagmo-move along with the cells yung references natin. Okay? So kunwari, if I move this to the right, gusto ko na ito minus ito, magmo-move din siya. Ay, bakit to the 22? To the 2 lang dapat. Okay? Parang ganyan. So ito, nag-move din to the right yung ano ko. And if I move it downwards, sorry. Then mag-move din downwards yung reference cells ko. Okay? So kaya ito yung gagawin natin. Okay? So this is now my parang chi-square table. Tapos gawin ko na lang is, it's the summation of all these values. No? So if I do sum nito, then I have my chi-squared calculated here. Okay? So to get my chi-squared na critical, what I'll do is equals chi-square dot inv dot rt kasi right tail test to. Tapos yung probability ko is yung alpha 0.05. Tapos ang degrees of freedom natin is equal to r times c minus 1. Tama? Let me double check. Sorry. Ang degrees of freedom natin is shown here pala, no? Itong new. R minus 1 times C minus 1. Okay? So that's R minus 1 natin is 2. Sorry. That's 1 multiplied by 3 minus 1, which is 2. So 2 siya. This is 2. Okay? Tama nga ba? 1 times 2. Tama. Okay? So that's my degrees of freedom. So I should get 5.99. And since chi-squared calc is greater than chi-squared crit, then we reject the h naught, no? Because our value now is in or within the pasok tayo dun sa critical region, no? Okay? That's one way to do it. Pwede rin, instead of calculating for chi-square crit, pwede ang ginawa natin is kinumpute lang natin yung p-value, no? So if we compute for p-value, it's chi-square dot this dot rt kasi gusto natin yung right tail again. Ng value na to. Tapos degrees of freedom niya is 2. Okay? So you get 0.019. Okay? So pwede rin ang natin, conclusion is since p value is less than alpha, then we reject h naught. Okay? Parang ganyan. Now, a quicker way to do this is instead of computing for itong expected, itong table na to, and magko-compute kayo. So these are the two tables na generate natin, no? Ito, tsaka ito. Instead of creating these two tables here, pwedeng ang gamitin na lang natin is yung Excel function ng chi-square test, no? So dito sa chi-square test is mas madali siya kasi if you do p-value, and this is for para lang ma-indicate, no? From chi-square.test. So if I just do chi-square.test and actually kailangan pala yung expected range pa rin, no? And I select the actual range, tapos comma, select the expected range. Then I get the same p-value, no, without calculating itong chi-squared na to. Okay? So it's a faster way to do it. Itong p-value na to. Or your other choice is, and kailangan ko ata ipakita to. Your other choice is to do ito no, yung data analysis tool pack. So you go to data, data analysis. Tapos hanapin natin yung chi-square test. So where is the chi-square test? Ako meron dito eh. ANOVA, single factor, ANOVA correlation. Wala pala. So walang default na ano no, data analysis tool pack. So baka kailangan mo i-download pa yung plugin na yun. Pero anyway, itong approach na to, yung chi-square.test is good enough no to determine the p-value. Okay? So I suggest na ito na lang yung gamitin yung method. So para hindi na kayo mag-create ng itong additional table na to no. Okay? Okay ba? So, chi-square test, pag ginamit niyo yung shortcut is quite simple, no? Mas madali siyang ah, gamitin as compared to yung mag-ano pa kayo, yung mag-create ng yung itong itong observed minus expected over observed na table, over expected na table, no? Okay? So, one note dito sa chi-squared na ano natin. So, if you look at this, no, itong yung formula natin for degrees of freedom, which is R minus 1 times C minus 1, is that if you have, for example, a 2 by 2 na contingency table, kunwari, so kung two levels lang ang two factors na ina-analyze nyo, you'll notice na yung degrees of freedom niya will be equal to 1, which is hindi pwede, no? Hindi pwede kasi magkaroon tayo ng degrees of freedom equal to 1. So for cases na meron tayong 2 by 2, meron tayong tinatawag na Yates correction of continuity, no? So for this one, instead of just doing observed minus expected uh, over expected, lalagyan natin ng minus 0.5 sa loob ng squared na quantity, no? Okay? So yan yung correction natin. Okay, so let's try, pero I believe na si Yates correction is already applied directly pagka ano no, meron tayong pag ginamit natin tong yung chi-squared dot test na equation, no. So to do that, let's just try no, copy lang natin siya para yan. Tapos ang gawin natin is let's just remove this high value, no. Okay? So remove lang natin siya. So if we do the first method, no. So let's do chi-square. Gagawin natin is create tayo ng table. Tapos the formula is equals the absolute value of this one minus this one. Tapos apply natin yung Yates correction, no, which is merong 0.5. Tapos squared divided by expected, which is this one. Then we get ganito. Okay, and then we can drag it. Then to take the chi-square chi-square calculated is equal to just the sum of this one. Tapos if we do chi-square a p-value, then we do equals chi-squared dot this dot rt. Pwede nga to. Tapos this one, degrees of freedom natin is equal to 1. Okay? We get 0.09. No? Now let's test if your p-value from the chi-squared dot test gives us the same, no? Does it apply the Yates correction immediately? So if you do this, you'll see na iba yung result niya, no? So hindi niya ina-apply. Let me double check, no? Because if I remember, ang alam ko, ina-apply niya dapat eh. So that's observed minus expected minus 0.5 squared. Tama ba yung inano natin? Observed minus expected divided by expected. Tama naman. Observe. Over observe. Okay? So, um, itong chi-square dot test does not apply Yates correction, no? And we can look at the documentation. Tingnan natin kung number one chi-square test chi-square test. Tingnan natin kung meron ba siyang sinabi about Yates correction, no? Okay. So this is one thing you can also do, class, no? Kunwari, if you're not sure if something gives you the value you really want, pwedeng tingnan niyo yung documentation niya. And dito walang mention din ng ano, no? And you can see na ito yung formula na ginamit niya, which is the same formula na ginagamit natin, no? So usually naman pagka nag-ano kayo, pagka tinignan niyo yung documentation ng isang Excel function, ibibigay naman sa inyo kung ano yung formula na ginagamit nila para maka-arrive tayo ng ganun. Okay? Tapos meron din sila mga example data na ah pwede nyo tingnan, no? So, for example, ito. So, this is 2 by 2. Di 2 by 3 pala to. Sorry. 3 by 2, I mean. Okay? So, si chi-square test does not give you, does not account for Yates correction. No? So, if you have 2 by 2, kailangan yung manual yung gamitin nyo para ma-account nyo yung Yates correction for continuity. Okay? So, that's chi-square test. Try naman natin to. This is a larger data, no? So, try natin yung data set na to. And you can do this with me, class, no? While I'm doing it. Para makapag-practice din kayo. And for this, delete ko lang to, no? Huwag ko na lang delete. So, let's try this one. Gusto natin makita if the H naught natin is the type of crime and the area and the district area are not dependent to each other. Tapos yung natin, H1 natin is the type of crime and the district area are dependent to each other. Okay? Tapos alpha natin, may sinabi ba doon? Kung walang sinabi, let's assume 0.05, no? Sinabi pala 0.01. Okay? So we can do alpha equal to 0.01. Tapos ngayon, i-compute na natin yung test statistic, no? So ito, first natin gagawin is create tayo ng observed, no? Expected, I mean. So ito yung observed. Create tayo ng expected table. And the expected table is equals sum nito. And I want that, sorry. Gusto ko magbago yung row niya pero hindi yung column, no? So I'll toggle such that yung letter yung may dollar sign multiplied by sum nito. And gusto ko naman na yung may dollar sign is yung numbers, no? Okay? Kasi gusto ko fix yung numbers. If I move to the right, dapat yung columns yung nagbabago. Okay? Tapos, divided by yung sum, grand total nito, which I don't want to move at all, no? So, lalagyan ko ng dollar sign both number and letter. Okay? So, and just to quick look lang, no? If tama yung ginawa ko, dapat ito, nandito, and nandyan. Okay? So, yun usually yung ginagawa ko, class, no? Especially when I do yung yung mga formula na dinadrag ko, which I place na the dollar signs, no? Para ma-fix. Take lang ako ng random column or row combination. Take a random cell, tapos check ko lang kung if it behaved exactly as I wanted it to behave, no? So, ito, tama naman. Ito yung expected behavior ko. Therefore, I can assume na siguro tama naman yung lahat ng yung iba, no? Okay? So, from here, I'll just directly compute p-value, no? Hindi na ako dadaan sa, no? So, I can do chi-squared dot this dot rt ng, sorry. I can do chi-squared dot test, para yung mabilis na method lang gagamitin ko, no? Actual, expected, and I get a very low p-value, no? That's almost close to 0. That's times 10 to the negative 25. Then, therefore, conclusion is since p-value is less than alpha, then we reject h naught, and therefore we can say the type of uh, therefore the type of crime and the district area are dependent to each other. Okay? So, yan. So, ito, yung quick method yung ginamit ko, no? Which is very convenient. Kailangan lang tama tong, itong expected na value, no? Okay, so that's chi-squared. Very simple. Dali lang siya gawin. Ang mahirap lang dito is determining if the data set indeed is appropriate for chi-squared na distribution or chi-squared na test, no? So, again, ang pinaka ma-suggest ko sa inyo na tingnan nyo is just look at the type of data, no? If it's a frequency type of data, most likely chi-squared yung gusto natin gawin sa kanya. Okay? So, later if I'll show you another type of data set, no, and you'll see na you will figure out na yung ibang data set obvious na hindi siya na frequency type of data. Okay? Okay, so we proceed with completely randomized design naman. So sa completely randomized design, what we are trying to do here is gusto natin na we are looking at um we are looking at one factor, tapos gusto natin i-check kung yung factor na yun is can affect the response variable, no? Okay? So yung H naught natin dito would be an equality, no? So this is for if you have more than one factor. So parang sinasabi mo mu1 is greater than mu2 is greater than mu3, etc. So this is saying na yung mu nung level 1 ng factor is equal to mu ng level 2 ng factor is equal to mu ng level 3 ng factor, etc. etc. Parang ganyan. So you might be wondering, no, baka ngayon na parang nagtataka kayo kung bakit at least nung ako, no, yung first time ko nakita to, ito din unang pumasok sa isip ko. Bakit I'm trying to make an inference about the means of the treatments by analyzing its variance. Parang hindi nang make sense, no? Kung gusto ko mag-make ng analysis on the means, dapat yung mga z-test, t-test, dapat yun yung ginamit ko kasi yun yung analysis on the means, no? Pero bakit yung variance yung tinitingnan ko? Okay, so the concept of analysis of variance is that parang yung observed na or the way we think about it is if a factor affects a response variable, then therefore introduction of that factor should disrupt the variation of the sample, no, or of the data set. Tama? Does that make sense? So kunwari, if we know that kunwari temperature affects the temperature affects a process kunwari. If we vary the temperature, then it makes sense na when we take the data, no, data of different temperature settings, dapat expected na nag-vary yung variance niya. So kumbaga, sobrang lumaki yung variance niya specifically because nag-introduce ka ng isang factor that affected the response variable. Tama? Pwede yung ganun siya isipin, no? Kasi kunwari, if the temperature did not affect the process, then therefore, yung variance na ma-observe natin is specifically due to, or is particularly due to chance lang. So, parang pwede nyo balikan yung, no, yung video, kung naalala nyo yung parang highly unlikely na due to chance lang siya. Kaya siya we say na yung sinend ko na ano no, yung probability na video dati. So pwede siyang i-analyze na parang ganun. And again, the simplest way to look at it is if a factor is introduced tapos it introduced some form of variation, that variation is not due to chance, pero yung variation na yun is due to the introduced factor, and therefore we can say na dahil in-introduce mo yung factor na yun, nagkaroon ng change doon sa response variable natin. Therefore, dependent si response variable doon sa factor that caused the change in variation. Okay? So that's why it makes sense to look at or it makes sense to analyze the variance to make a conclusion about the mean. No? Okay? So I hope I've given you some parang ano no, clarity on why we do an analysis of variance, no. Okay, kasi for me, for the longest time, I was always wondering, no, bakit gumagawa tayo ng analysis of variance? Tapos yung kino-conclude naman natin, hindi has nothing to do with the variance at all, no. Parang kino-conclude natin if significant ba yung isa versus sa isa, parang ganyan. Okay? So, the way we do this is you can state it like this, no, na kunwari yung mu1 is equal to mu2, and depending on the levels, no, is equal to mu3, etc. But we can also state it in terms of parang ano no, using ano lang, yung simple terms like kunwari, pwedeng ang sabihin natin is factor A has no significant effect on factor B o on response variable. Or tapos yung alternative natin is factor A has a significant effect on the response variable. Okay? Okay, so for me, if when we do ANOVA, it's always easier to state it that way, no, instead of stating it like this, no, kasi minsan confusing tong ganitong statements or hindi readily kita sa observers natin or yung audience natin, yung readers natin kung ano yung gusto nating assertions na or what assertions are we trying to make, no. Okay? So, dito, let's do this example, no. So, meron daw tayong manufacturer of paper that is used to create grocery bags. Tapos interested yung product engineering team na i-investigate kung yung tensile strength ba is affected by the hardwood na concentration in the pulp, no, when you are creating the paper. So, ang range ng hardwood concentration of practical interest of the team is between 5% and 20%. Okay, so eto, usually class, how we determine the levels is through ano no, parang knowledge of the subject. So for example, etong product engineering team na to, they know that they are working with mga 5% to 20% yung usual process nila. So it would be of their best interest na doon sila maglalaro. Kasi kunwari, anything less than 5%, by experience, alam nilang hindi na mag-work. So dapat mag-investigate sila 5% pataas. Tapos alam nila na kunwari anything above 20%, masyado nang mahal yung process nila. So kunwari, the more pulp you add, the higher the cost. Tapos anything above 20% hindi na practical. So kaya sila nag-analyze ng 5 to 20% lang. Okay? So you need to think about that, no? Lalo na pag nag-experiment kayo or nagti-thesis na kayo, hindi lang random tong pagpili ng factor levels, no? Usually, pumipili tayo ng levels based on expertise natin sa subject, and the way we come up with that is either through experience or in your case, pwedeng through review of related literature. No? So titingnan nyo yung review of related literature nyo. You look at different previous studies or you look at parang practical applications, tapos tingnan nyo kung ano yung useful na ranges for which may bearing yung or may significant na parang kung yung conclusion nyo can have a significant impact on the industry that you are trying to do the experiment for, no. Okay? So, dito first gusto natin i-establish kung ano yung response variable. So, if you look at this, alin yung response variable at alin yung factor? So, pwede nyo i-chat. Right now, this should be obvious to you guys, no? Kasi isa to sa skill na kailangan nyo para makapag-properly do ng experiment, no? So lalo na sa mga studies na gagawin nyo eventually. And ito din yung nung nag-interview ako ng certain groups, no? Hindi nila masyadong ma-pinpoint kung alin yung response variable at alin yung factors, no? So kaya it's a good exercise na gawin natin to. So Russell says response is tensile, independent is si hardwood concentration, which is correct, no? Tama. So response, yun yung tinitingnan natin. This is the direct measure. I'm sorry, yung tensile is the direct measure kung sa objectives natin, kung nagsistrengthen ba siya with the change in hardwood concentration, which is now our factors, no? Okay, so we're doing one-way ANOVA lang dito. So we have only one factor and we have several levels, no? And in this case, we have 4 levels actually. So 4 levels tayo, 5, 10, 15, and 20. Tapos, so that means na 4 levels, you have 4 levels, tapos ang ginawa is 6 test specimen per level. So we have a total of 24 specimens. Okay? So ito siya. So ito lang talaga yung data natin, no? Itong or ito lang yung treatment combination natin because we only have one factor. So ang treatment combinations natin is naka-low level si factor A, medium low, tapos medium high, tapos high. That's 5, 10, 15, and 20. Tapos ito, these are just replicates, no? Itong observations na to. Okay? So to do one-way ANOVA, we need to formulate first yung hypothesis natin, no? Similar to hypothesis testing. So the hypothesis is, again, instead of doing this na mu1, this is just the mean of level 1 or 15% is equal to the mean of the mean of 5% is equal to mean of 10% is equal to mean of 15 is equal to mean of 20%. Okay, instead of doing this, pwede lang the different hardwood concentrations do not affect the mean tensile strength of the paper. So ako, I like to state it this way, no? Lalo na pag-ANOVA. Tapos pagka naman H1, at least 2 of the means are not equal. So pwedeng mu1 is not equal to mu2 or mu1 is not equal to mu3, etc., etc. So you can do all the permutations for that, no? So or combinations for that taken 2 at a time, no? Pero you can just simply state that the different hardwood concentrations does affect the mean tensile strength of the paper. Okay? So the usual values for alpha is yung 0.25, 0.1, 0.05, and 0.01. Pero usually we just take 0.05 no, if not given. Kasi yun yung parang standard pag for the sciences, no? Sa at least for engineering, yun yung standard, no? 0.05 yung ginagamit natin. Now, here, we will use the F tables, no? So for analysis of variance, F distribution yung tinitingnan natin. Now, dito, yung F tables natin is taken from yung nu natin. Nu 1 is just equal to the number of factor levels minus 1. Tapos yung nu 2 natin is the total number of observations minus the number of levels. Okay? So we do etong sum of squares, importante to know kasi most of the formulas na gagamitin natin involves computation of the total sum of squares, so SST. Tapos kahit sa future natin ng mga computations, we will always have sum of squares na SST na value na kailangan natin i-compute. Okay? So try lang muna natin 'to. So we get, kunin natin yung data natin. This is our data. Lagay natin dito. Okay. So, gawin natin is, compute lang natin yung SST muna. So SST, the easiest way to compute for SST is to do sum square. Sorry. Before we do that, lagay tayo ng tinatawag natin correction factor, no? So correction factor, tama pala. Sige, papakita ko mamaya, no? Yung Excel, nakalimutan ko. Sorry. Thank you for the reminder, Russell, no? So ito, if you look at the formula, you can do it in 2 ways, no? Pwedeng ito, and this is the simplest way to be executed in Excel, wherein kukunin natin yung sum of squares ng lahat ng individual observations squared o sum ng lahat ng individual observations squared minus itong value na to, no? This is just yung sum, this is the grand total squared divided by n. Okay? So, because this value is often used a lot, ang tawag natin dito is the correction factor, no? So minsan it's always easier to um, get a calculation of this value. Parang i-separate nyo na siya, hiwalay nyo na siya para pwede nyo i-reference yung cell na yon each time you need the correction factor. Okay? So you'll notice sa next few lessons na gagawin natin, no, the correction factor will always come up, no, or will most of the time come up, and therefore parang maganda na rin na i-separate natin yung calculation for this one. Another way to do it is pwedeng gawin yung ganito, no? This is yung individual na observations natin, i-minus natin by the average na data and you square it. And ito medyo mas ano siya, no? Mas tedious tong or mas mahirap i-execute to using Excel. So I highly advise against using this, no. Ito lang yung gagamitin natin. Okay? So lipat tayo sa Excel. Ito siya. So let's first compute the correction factor, and the correction factor again is just the grand total. So this is the grand total, no? Sige, para hindi kayo malito, no? This is observations, and I'll just place them in bold, no? Yung bold, naka-bold na letters, numbers, hindi yon yung data. Ito talaga ang data set natin. So this is just 5%, 10%, 15, etc. Okay? So, gawin natin is equals para lang hindi tayo Okay? Correction factor is sum grand total raised to the power of 2 divided by the total number of observation, which is if tulad nyo ako na medyo tamad magbilang, pwede nga gawin nyo lang is count. Ganyan. Okay? Oh. Sorry. Hindi ko pala napindot. Raised to the power of 2 divided by count B3 to G6. Okay? So I should get a correction factor equal to this value. Now to get SST, gagawin natin is sum squared ng individual observations, which is this one. And we deduct the correction factor from it. So this is my SST. Okay? So that's SST calculations. Tapos, compute naman natin yung SSA. So, minsan SSA, kaya siya tinawag na SSA because if you have multiple factors, no, usually we label the factors as factor A, factor B, factor C, factor D, etc. So, para mas madali siya matandaan, SSA, kumbaga SS sum of squares ng factor A, sum of squares ng factor B, etc. etc. Pero dito, since we have only one factor, ang tamang paglagay talaga nito is SS treatment, no? Parang ganyan. Kasi ito is SS total. Pero medyo mahaba kasi yon. So usually what we like to do is SST lang tawag natin dito, tapos SSA yung tawag natin sa treatment. Okay? So SSA or the SS of the treatments, and since we only have one factor, no? So si factor A is just the one factor that we are looking at. Okay? So SSA has this formula, no? Again, this is the SS treatments, SSA. Equal lang siya sa sum ng individual na observations between the treatment means, no? Divided by the total number of observations from which we took this sum right here. Okay? Minus minus the correction factor again. Okay? So, to put it into perspective, ito siya, kukunin lang natin yung column total, row total I mean. So, ito yung sum ng lahat ng observations that fall under a particular na factor level. For example, itong 5%, if you take the sum, ito yung 60 na yon, and we squared it divided by the total number of observations which form this 60 value. Okay? Kasi there are cases wherein, for example, you can do you can you can do ANOVA without having equal number of observations actually, class, no? Kasi kunwari, if you have only 3 observations for hardware concentration dito, kunwari itong hardware concentration na 10%, pwedeng kunwari dahil sa gross error, no, meron kayong mga mali sa experimentation, you only got 3 observations, tapos itong 4, 5, 6, yung fourth, fifth, and sixth observation nyo, parang nag-fail yung sample nyo or may mali kayong nagawa doon. Pwedeng, ang mangyayari is, may exclude siya sa dataset nyo. So, you will be ending up with 3 observations dito. And you might think na, kailangan ko pang magdagdag ng 3 more observations. You can do that. You can add more 3 observations. Pero kung kulang na kayo sa time, you can actually analyze your, ano no, kaya pa rin ma-analyze yung ANOVA natin simply by just varying the divisor, no? So, anytime you see these types of formulas na kunwari SSA, lalo na pag nag-SSA, SSB, SSC na tayo, the way you always think about it is yung value na sin-square nyo, yung denominator niya will always be kung ilang individual observations ang nagme-make up doon sa data na yun. So, kunwari, itong 60 na to, this 60 comes from 6 individual values. Therefore, 6 yung magiging divisor na. And you can also look at it sa ano, no? Ito kunwari, itong sa SS total natin. If you think about it, itong 7 squared, ang divisor niya is actually just 1. Tama? Kasi parang itong 7 na observation na to, total siya ng only 1 observation, which is this individual observation. Kaya over 1 siya. So parang sa lahat ng SS na formula, ganun parati yung ano natin, no? Yung parang treatment. You take a sum of square of a parang either a group of values or an individual value. Tapos i-divide mo parati doon sa kung ilan data set or ilang observations, individual observations ang nagme-make up ng value na sin-square nyo. Tapos, pag in-add nyo total yon minus parati yung correction factor. Ganun parati yung form. It does not change, no? Parati pag SS yung sinosolve, always ganun, or almost always ganun yung form niya. Okay? So, dito sa case na to, we are taking row totals kasi gusto natin makita yung observation in between treatments. So, kaya 5, yung 5% versus a 10% versus 15 versus 20. Therefore, kukunin natin yung row total na to to get yung parang observation that relates to 5%. Okay? So, ito kukunin natin yung 60 and because it's made out of 6 observations, over 6 siya. And conveniently, ito, lahat naman naka 6 observations kaya pwede natin i-divide lahat by 6. Okay? Tapos minus yung correction factor ulit. Again, this is just the correction factor. Okay? So, let's try to solve that in Excel. We do SSA is equal to, let's get the totals first. No? Sum of these values. Tapos, drag down lang natin. Okay? Tama ba? Okay. So, this is just the total. No? So, gawin natin equals. Actually, hindi natin kailangan yung averages. No? Minsan, kinukuha lang yung averages if you want to do the other formula. No? Kasi, kunwari, let me go back. Another way of computing this is to get the, itong average niya minus the individual average, yung total average. So, pwedeng ganun din. Pero again, I advise against this kasi mas mahirap siya gawin or i-execute sa Excel. No? Okay? Balik tayo. So, eto, SSA natin equals sum square ng itong individual values na to divided by each individual value na to. Itong total na to comes from 6 individual observations. Tama? So, kaya divisor natin is 6 minus yung correction factor which is which gives us 382.79. Okay? So, we have SSA, SST. Kailangan na lang natin is yung tinatawag nating SS error, no? So, the SS error is just the total observation, total sum of squares minus yung SS ng treatments. If there are multiple SS treatments, then magiging SSA to minus SSB minus SSC minus SSD, etc. etc. Ito, pwede rin makompute siya using this formula. And again, I highly advise against this kasi mahirap i-execute sa Excel. No? Okay? So, dito, pwede natin makompute by just taking the difference between the total minus the treatments. Now, this is where kailangan natin yung ano, no, tinatawag na ANOVA table. And I'm expecting na by the end of this lecture, uh, you are familiar with ano na, no, how the SS table is laid out kasi lahat ng or sorry, how the ANOVA table is laid out kasi halos lahat ng ANOVA tables will have a similar na form, no? So hindi naman nagbabago to. So kailangan at least ma-memorize niyo na kung ano yung pini-fill out natin sa SS table. So SS error is just eto minus this one gives us 130. So let's do the ANOVA table. No, ANOVA table, always sa first column we do source. Source is just kung ano yung uh, tinitingnan natin na sum of squares, no? So whether it's a total sum of squares, it's an error, or it's a treatment. So dito sa source natin, we can do source A, or we can do A, or pwede rin sabihin na natin hardwood concentration. Or para mas simple, no? Gawin natin concentration na lang. Concentration. Parang ganyan. Okay, so this is our factor A. Tapos, ang next natin is the error. And yung last, by convention, parang mas maganda lang na nasa dulo yung total, no? Tapos, error is this one. If you have another factor, kunwari, tinitingnan din natin yung temperature, pwedeng ganyan. Tapos, pwede rin ganyan yun, no? A, tapos B. Pwede ganyan. Since we have only one factor, concentration lang ilalagay natin. So, first is source. Next is SS or sum of squares. So, sum of squares natin is equal lang siya dito. Sum of square nandyan. Sum of square ng error is this one. And sum of square ng total is equal to this one. Okay? So, meron tayong sum of squares. Ang next value na i-compute natin is the degrees of freedom, no? Okay? So, DF. So, DF, the concentration, itong sum of the degrees of freedom for our factor is just equal to yung factor levels minus 1. Okay? So we have, how many factor levels do we have? We have 4. Therefore, ang degrees of freedom nito is just 4 minus 1. Okay? That's 4 minus 1. It gives us 3. Tapos, yung error natin is the total number of observations, which is, again, gagawin ko lang count to, but this should be 24, no? 24 minus the number of levels sa factor ko. So the number of levels I have is 4. Okay, so this gives me 20. And if I take the total, it should be equal to if I add this equals eto plus eto, that should give me 23. Another way of computing SS total is just the total number of observations. So 24 minus 1. Okay, so which also gives me 23, no? So ako, personally, ang ginagawa ko is, I just do, kasi ito, madali siyang compute, no? Itong concentration, parang madali ma-imagine, n-1 lang. So, I can do yung number of levels ko, minus 1 gives me 3. Tapos, usually, ang ginagawa ko sa total, kasi ang alam ko parati, parang standard kasi or parang very common na yung degrees of freedom is some count minus 1. Parang ganon. So, mas maganda sa akin na gawin ko is count ito minus 1. Tapos, itong error, para hindi ko na i-memorize yung formula for error is, kasi yung error, nagbabago kasi yung formula na every time, no? Kunwari, pag may two factors ka, pwede, hindi lang n minus a yung mangyayari, no? Or yung number of total observations minus factor levels. Hindi lang gano'n, no? Parang, depending on the type of test, mag-iiba yung form ng formula niya. So, I just like to do is, si error, always ginagawa ko na lang total minus yung sum ng mga degrees of freedom ng factors ko. So, if I have multiple factors, magiging 23 minus, kunwari, 3 sa concentration level, 4 sa temperature, 1 sa whatever factor, additional factors there are. So, pwede ganyan. So, ito yung simplest way to do it, no? Error is just kung ano yung difference between the total and the and the factors. Okay, so after degrees of freedom, we next have your um, mean square, no? So we call this as MS value. So MS value is just yung SS natin divided by DF. Okay? So ito, pwede ko nang i-drag down. Ganyan. And hindi na actually natin kailangan yung MS ng total, no? Kasi hindi naman kailangan yung mean square ng total. So hanggang error lang tayo. So ito, MS, we call this as MSA. Ito yung MSA. Ito yung MSE. Tapos kung meron pa tayong in between na factor, pwedeng may MSB, MSC, MSD, etc. Okay? So, ito, what's important about itong MSE is when we compute for the F value, si MSE will always be the denominator. Okay? So, for example, uh, if we are to have, kunwari may MSB tayo dito, yung next column kasi natin will be the F calc, no? And F calc is always MS ng source natin divided by MS ng error. Okay? In fact, pwede kong i-dollar sign to na ganyan. So let's just say na meron akong kunwari 150. Ito yung sa MSB ko. So pag dinrag ko siya, ito dapat siya. MS ng B divided by MS error. MS error will always be the denominator. Okay? So notice how ito F-calc, this is numerator divided by denominator, no? So therefore if you're looking at tables, no, the numerator will be DF1. Ito parati yung degrees of freedom 1 mo, itong 3. Tapos degrees of freedom 2 mo will always be the denominator, which is 20. Okay? So delete lang natin to. So we have F-calc. So now we can make observations. So pwedeng next is pwedeng F-crit or pwede ring p-value depending on what approach. And the last table na gagawin natin is conclusion naman. Okay? So pwedeng ganito yung ANOVA table natin. Okay? So let's do F-crit. Kung F-crit yung gagawin natin, then we do F test, F dot test, F dot uh, F dot inf dot RT, kasi again right tail test parati, no, pag nag-ano tayo analysis of variance. Then the probability is sabi 0.01 daw gagawin natin, no? So 0.01 degrees of freedom 1 natin is numerator, which is 3, denominator, which is the errors degrees of freedom. So 20. Okay? Then we have this value. So we can make a conclusion, no? Since F-calc greater than F-crit, reject H0. Okay? Or if we take p-value equals f dot this dot rt ng x na to, degrees of freedom again is 3 and 20. Tama? 3 again comes from degrees of freedom ng numerator, which is this one. And degrees of freedom ng error is the denominator, which is always the error. Okay? So we have, again, a very small value, no? So pwede rin ang conclusion natin dito is and I can just make this as one conclusion. Since F-calc is greater than F-crit and p-value is greater than, pwede rin para mas madali, no? Pwede nyo gawin ganito na lang. P is greater than alpha para hindi nyo na tinatype parati yung p-value na term, no? So since p is greater than alpha, then we reject H0. Therefore, ang magiging final na ano natin is ano ulit yun? We can say that hindi ko kasi sinulat yung H1 at H. Dapat sinulat ko muna yung H1, H0 at HA, no? Pero we can say that therefore the concentration level has a significant effect on the ano yung response natin? Tensile strength of the paper. Pwede ganyan, no? Sorry. Thank you. P is less than alpha siya. Kasi dapat mas malit yung area natin doon sa area sa right side. Thank you, Russell. Okay. So yun, you can do this, no? Ito yung long method to do one-way ANOVA. Pero yung shorter method, and Pico, baka ito yung gagamitin yung method na madalas, no? if you take, you can act, there's actually a built-in function, no? So we can do data, tapos, let's do data analysis. Ay, sorry. Parang hindi lumalabas. So, ulit. So we do data dito. Sorry, data. Tapos punta tayo dito, data analysis. Tapos again, ang gagamitin natin is ANOVA single factor. Kasi one-way ANOVA lang to. Itong ANOVA single factor, okay. Input natin yung range natin. So we can include the columns, no? So ito, kunwari ito. We can include the labels, I mean. So we do until here. Tapos this is grouped by, dapat specify nyo, no? So dito, naka-group siya by rows, no? Kasi yung rows natin indicates the different na, kumbaga, levels ng factors natin. So this is very important, class, no? Dapat dapat tama yung pagpili nyo ng either group by columns or group by rows siya. Okay? So in this case, group by rows to. Okay? Tapos you label, you have labels in the first column, which is ito 5, 10, 15%. Alpha natin is should be 0.01. Okay? Now we output the range. Lagay lang natin dito sa tabi, no? Para may comparison tayo. Let's do kahit dito na lang. Lagay ko lang dito or pwede na siguro dyan. Okay? And if I press OK, you are given an ANOVA table, no? Okay? So, sige, mag-insert tayo ng more rows, no? Okay. Parang ganyan siguro. Okay? Zoom out lang ako konti. So, ito, you'll see na um, same lang yung values na nakuha natin, no? So, we get SS 382. Ang sinasabi dito, between groups, parang sinasabi dito is, this is the treatments, no? And within groups is the error. Okay? So, you can see na yung source natin, ito 382, same with 382, 130 ang error, total is 512. Then we have degrees of freedom, 3, 20, and 23, 3, 20, and 23. MS, 6.5 for the error, 127 for the treatment. Okay, then FCalc, I mean, and usually si Excel, yung capital F, yun yung FCalc niya. So FCalc is 19.605, which is the same as this one. FCrit niya is 4.9. 4.9 din dito. P-value is 3.6 times 10 to the negative 6, which is the same as this one. No? 3.6 times 10 to the 6. Pwede nating i-ano. Para same talaga sila. Yan. So, pwedeng ganyan. 3.6 times 10 to the 6. Tapos, conclusion. And pwedeng dagdagan nyo na lang ng conclusion dito. No? Okay? Tapos, kung OC kayo, pwedeng i-copy nyo yung format painter. Paint nyo dyan. Para same format siya. Okay? So, you can do conclusion here. And we can make the same conclusion. Ito, I'll just copy this. Paste ko lang dyan. Okay? Okay? So, you can do the quick method, no? It might be easier for you, pero sometimes there are advantages to do the longer method, no? Ano bang advantage nito? Siguro para mas ano, no? Sometimes kasi baka malito kayo kung arrange by column siya or arrange by rows. So minsan parang vague siya, no? Pero para mas feel nyo yung data nyo pag manual nyo siya or quote unquote manual. Kasi technically you're still doing this quicker than the manual method na nag-pen and paper talaga. Okay? So kayo bahala kung ano yung comfortable method nyo. You can use this, no? Very quick, basta just be vigilant kung ano yung values na yung mga different na options na kailangan yung i-take para tama yung results na makukuha nyo. Okay? So before we proceed with RCBD or complete block design, meron bang tanong about this? Kaya ba? Madali lang naman. Or may confusing part ba? I'll give you a few minutes, no, to try to think of yung difficulty nito. in general, no, Fico, most students tend to prefer ano, no, yung data analysis toolpack kasi it's quick, it's easy, tapos well arranged na yung ANOVA table once lumabas siya, no. So as long as you master the data analysis toolpack, feel ko naman madami kayong kayang gawin. Pero yung problema lang sa data analysis toolpack, hindi lahat ng ano natin, uh, hindi lahat ng tests na na discussed dito sa course na to is covered by the data analysis toolpack, no. There are certain na methods na hindi covered sa analysis toolpack and therefore kailangan nyo mag-manual. Okay? No questions? Can we proceed with complete block design? Randomized complete block design or RCBD? Thumbs up or like or yes para makapag-proceed tayo. Okay. Okay, thank you for the feedback, guys. Okay, let's proceed with complete block design, no? Let's do complete block design. And balik tayo sa ano natin. Okay? Ito, okay na tayo dyan. So, ang ano natin, complete block design is instead of just looking at ano, no, ito sa another sample example ito. Ito, complete block design tayo. Instead of looking at one factor alone, pwede tayong actually gumawa ng tinatawag na blocking, no? So, yung blocking is arranging the experimental units into different groups or blocks that are similar to one another, no? So, ang goal nito is we want to reduce known variability. So, for example, you are analyzing, kunwari, um, you are analyzing a steel na ano, no, parang yung kasi a better example siguro yung mas makita natin. For example, nag-analyze kayo ng traffic. Okay? So you're analyzing traffic, tapos ang tinitingnan nyo yung uh, yung factors na tinitingnan, yung isang factor na tinitingnan nyo is yung time of day. Yun yung main factor na gusto nyo i-analyze talaga. Does the time of day affect the traffic? So pwede naman pwedeng i-one-way ANOVA yun, no? So you can do one-way ANOVA sa traffic lang and you can still get reasonable na conclusions from it. Pero if you want to reduce the variability, pwede ang gawin natin is i-block natin siya in such a way na uh, kaya natin ma-reduce yung known variability because we already know that it affects. Pero not necessarily gusto nating aralin. So kunwari, hindi tayo interested kung aralin kung yung type of weather ba nakaka-affect sa traffic. Alam lang natin na ang gusto lang natin is malaman yung time of day, does it affect traffic? Pero uh, based on our experience, we know that usually pag umuulan, mas nagta-traffic siya kumpara sa kunwari sunny. Tama? So we know that the type of weather does affect it. We know that it introduces variability either through experience or through our expertise. And therefore, um, if we want to reduce the error of the experiment, then ang gagawin natin is i-account natin yung variability na yon. So pwede natin i-group yung data natin with time, pwedeng time, tapos i-block natin siya according to weather conditions. So by doing that, actually nare-reduce natin yung error ng experiment. Okay? So the way we treat this is it's as if yung block natin is a second factor. And you will later realize pag next lesson tayo, no, you will realize na the way we compute for RCBD is the same method na gagamitin natin for two-way ANOVA, no. Pero ang difference lang is that yung blocks natin, we are not treating it as a ano, no, hindi natin tinitreat siya as a factor, pero tinitreat lang natin siya just as a method to reduce the error or reduce the known variability. Okay? So, again, kailangan lang ano, no, very careful lang tayo on how we treat complete block design. So it can be tempting to view the block as a second factor, pero again, this should not be the case, no? The blockings were just introduced para ma-reduce natin yung variability. So another case wherein kaya importante na ma-recognize natin yung difference between a block and a factor is that um, importante din kasi na when we say factor, usually, di ba, from the workshop that we did is factor is something that we can control, no? So the reason why we analyze or we do these types of statistical tests is that eventually gusto natin na i-control yung factors na yon. So let's just say na you're doing an experiment, no? And kunwari you are doing um, yung different machines, kunwari. Does different machines produce different products? Yun yung gusto nyong i-test. So that does the type of machine produce different kunwari properties doon sa ano natin, sa products na pinuproduce ng machine. Okay? So yun yung ina-analyze natin. Pero there is a factor, another factor, kunwari that the person or the parang skilled personnel na nag-ooperate ng machine. Does the operator have an effect on the performance of the machine? So, intuition would tell you na dapat oo, no? Lalo na pagka yung operation ng machine is highly dependent on kung gaano kagaling yung operator natin. Okay? So, we know that the operators have an effect. Tama? But should we consider them as a second factor? So we try to think about it, no? So if we consider the operator as a type, as a factor, does this give us any control? Kunwari, kung ikaw company, ikaw manager ng isang company, kaya mo bang, kunwari, ang analysis mo is that the operator has a significant effect din. Bukod doon sa type of machine, operator also has a significant effect. So kaya mo bang maano 'yon, ma-control? Kunwari, kung sino yung pumapasok, kunwari sa shift mo, kung sino yung pumapasok na operator, kaya mo ba siyang ma-control? Is it something na pwede mong i-adjust such that ma-improve mo yung yield ng mga machines mo? So in that in most cases hindi mo kayang i-control 'yun, no? Kasi different operators can come and go at different na parang shifts. So randomized naman yung shift nila. So posible na hindi mo kayang makontrol 'yun. So hindi worthwhile na i-analyze mo yung operator as a factor. So ang gagawin mo is instead of looking at it as a second factor, i-treat mo lang yung operators as if ano lang sila, blocks lang sila. So you are just doing this para ma-reduce natin yung variability ng experiment. And later, makikita nyo na what it means to reduce variability, no, in terms of yung numbers mismo. Okay? So let's try this one. An experimenter administered meron ba tong ito na lang. Ito yung example natin kasi may data set to. So we have 4 different machines, M1, M2, M3, and M4 that are being considered for the assembling of a particular product. And it is decided that 6 different operators are to be used in a randomized complete block design. So ito yung example na sinasabi ko kanina, no? Yung operators and machines. So the amount of time in seconds were recorded for assembling the product. So test the hypothesis at 0.05 alpha that your machine performs at the same mean rate of speed. So meaning walang difference yung machines natin. No? So pwedeng hypothesis natin is, null hypothesis is the type of machine or there is no significant difference in the assembling rate with the or there's no significant difference between the assembling rate of the different machines. Tapos there is a significant difference. Pag yung alternative naman natin is there is a significant difference between the assembling rate of the different machines. Okay? So, the question here is obviously yung ano natin response variable is the amount of time, no? Yun yung assembling, yung rate of assembly for the product. Tapos etong different machines natin, yun yung factor na gusto natin i-analyze because we can control that, and yung operators i-treat lang natin as a block, no? Because in most cases hindi naman natin makokontrol kung sino yung operator natin. Okay? So ito, we have machine 1, we have different operators. Tapos wala tayong replications, no? So we have only one replicate for each uh, treatment combination natin. Okay, so ito yung mga treatment combination natin. We have machine 1 and operator 1, machine 1, operator 2, machine 1, operator 3, etc. etc. Okay, so let's take this data. Kunin natin yung data na to. Ah, hindi. Sorry. Dito pala. Kaya pala nagtaka ako. Ay. Picture pala to. So, sige. Yan natin. Copy natin one by one. So that's 42.5. Sabihan niyo ako kung may mali akong in-input class, no? 39.6, 39.9, 42.9, 43.6. Punta ko dito. 39.8, 40.1, 40.5, 42.3, 42.5, and 43.1. Next is 40.2, 40.5, 41.3, 3.4, 44.9. Tapos 45.1. Next is 41.3, 42.2, 43.5, 44.2, 45.9. Last is 42.3. Okay? Tapos arrange natin siya. Insert. We say dito is operator 1. Ilagay natin na ganyan. Operator 3, operator 4, operator 5, operator 6. Tapos ito, machine 1, machine 2. And actually, pwede pala natin i-drag to, no? Usually, smart enough si Excel na nakakuha ng pattern, no? Or ilagay mo M1, M2. Usually, siya na mag-fill out. Okay? So, pwede natin delete to. So, ito yung different ano natin, no? Ito yung data natin. So, first, compute muna tayo. Correction factor muna, no? Same formula lang actually. Correction factor natin is, again, grand total, which is the sum ng lahat ng dataset natin divided by divided by squared divided by yung total count natin. So that's count. Ito. Okay? So that gives us the correction factor. Okay? That's sum squared divided by grand total. Okay? Lagyan ko konting space, no? Kasi maglalagay ako ng totals dito. So this is my column total and maglalagay din ako ng row totals dito. So we can do equal sum. Itong values na to. Okay. Then drag it to the right. And I can also do equal sum ng totals na to. Okay. So ito siya. Ito yung totals natin for the left. Ay, ngayon ko lang naalala. Dapat pala in-invite ko yun. Anyway, sige. We have, ito siya is the grand total. Ito yung total um, ng operator 1. Ito yung total operator 2, etc. Tapos dito naman totals ng machine 1, machine 2, etc. etc. Okay? So if we take the sum nito, it should give us the same value as the sum on the other side. No? So that's 110.9. Ito, 110.9 din siya. No? So if you look at the bottom, you can also see na 110.9 siya. Pero nakatrim pala yung ano ko. Oh. Yan. So, one quick way to know the parang common statistics sa kanya, no, is just select your data set. Tapos tingnan nyo sa bottom. May makikita kayong average, merong count, merong 110. Okay? So, without actually computing for it. No? So, that's one quick way to do it. Okay? So, Pwede natin i-delete to, no? Hindi naman natin kailangan yan. So, correction factor, meron na tayo. SST naman. Solve natin si SST. SST is same formula lang ulit. Sum square ng dataset natin, and we won't include the totals, no? So, ito yung dataset natin sa yung mga observations. Sum squared niyan, divided, minus, kasi divided by 1 technically lang sila, no? Minus the correction factor. Yan yung SST natin. Okay? Now, let's do SSA, which is SS ng treatments. Tapos, we say SSB is, sabihin natin, ito yung blocks naman. Okay? So, SSA is just yung sum of square ng sum square ng etong values na to, sum of squares ng values na to, tama? Kasi ito yung ano yung totals ng different na means. So they are grouped by rows, no? So kaya ito yung kinuha ko. Tapos, ang sabi natin kanina is, yung divisor is the total number of observations that make up this total, tama? And you can see na itong total na to, it comes from 6 different operators or 6 different individual observations. Therefore, over 6 yung gagawin natin. Tapos minus, again, correction factor. Okay? So, parating ganun yung form niya, no? Yan. We have 15.9246. Tapos, SSB natin, the blocks is, we are looking at the blocks naman dito, no? So, dito, this is arranged by columns naman siya. So, if you want to get the blocks, it's equal to sum square ng totals na to by columns divided by, tingin nyo, ano dapat yung divisor dito? If we follow the same na logic. 4, that's correct, no? Thank you, Russell. So 4 siya kasi each individual value comes from 4 different na, or each total here comes from 4 different na individual observations. Okay, so we do 4 minus, again, correction factor siya. Okay. Now we can do our ANOVA table naman. So we do ANOVA. So first is, again, source yung una natin. Next is SS, source, that's sum of squares. Next is DF, or degrees of freedom. Next is MS, which is the mean square. Because after MS, we now have FCalc. Tama? After FCalc, we can do either p-value of FCrit. So pwedeng, dito sa built-in, inuunan niya yung p-value, no? So let's just do that as well. Tapos next is FCrit. Then we can have conclusion. Okay, so we do source first. Source is treatments, or para mas accurate, gawin natin machines na to, which is the treatments. Then we have our blocks, no? Blocks, which is operators. So we can do, para, kasi if I type operator here, baka you will think na operator is a factor. Para lang hindi siya confusing, no? Gawin natin blocks lang siya. And we can do operator. Okay, pwede rin, another way of doing it is you do pwedeng machines, and you say na ito yung treatment, tapos operator, and you'll say na block siya. So it depends on you guys, no, kung paano nyo siya gustong isulat, no? Then we have your error, then you have your total. Okay, so machines is equal to ito, A. Yung blocks natin is equal to B blocks. Error natin is just equal to total, and we input muna natin yung total, which is this one. So error is just equal to this one minus blocks minus treatment. Okay, so what do we mean by reducing the error? Now we can circle back to that yung statement na yun. Sabi natin, we are reducing error by introducing blocks. Okay, so say for example na ang ginawa natin is hindi natin tinitreat as blocks to, no? Ang sabi lang natin, kumari, replicates lang to. We have 6 replicates for each machine. Actually, same lang yung calculations, no? Ang only difference lang is meron tayong blocks. So, kung tatanggalin natin to, this is actually just one-way ANOVA. Tama? One-way ANOVA lang to. Ganito naman natin kinumpute si one-way ANOVA. And you'll notice na SS treatments natin, ganito din yung formula. Sum of squares nito divided by 6 kasi 6 replicates siya minus yung correction factor. Tama? Walang magbabago sa formula. The difference is lang, if you look at the error, 65.93935 siya. If we just did simple ANOVA, no? But because we did blocking, if we did blocking, so babalik ko yung 42, no? Ang mangyayari is from 65, naging 23 na lang yung error natin. So from the 65, kumbaga ang ginagawa natin sa blocking is from the 65 error, which is parang generally unknown siya, no? Hindi mo alam kung saan nanggaling yung error na yon. That is your value. Yung unknown na yon, parang nagdeduct ka ng 42 kasi alam mo na 42 from that 65 comes from the operator na variation. Okay? So essentially, ang nangyari is bumaba yung error mo dahil in-account mo yung itong 42 na to from that 65. Okay? So that is why blocking is important, class, no? Kasi binababa niya yung error na to. Okay? And why is bakit mas maganda na mas mababa yung error natin? For obvious reasons, no? Mas maganda naman parati pag mababa yung error, pero in terms of the numbers, if you remember yung F-calc natin is based on MS ng treatment divided by MS ng error. So if we have a lower MS error, and then therefore, mas mataas yung F-calc natin. Tama? Kasi kung lower yung denominator, mas magiging greater yung value natin. So kung mas mataas yung F-calc natin, mas malaki yung chance niya na makapasok doon sa critical value or na mas makapasok tayo sa reject H0 region, which is yun ang goal ng experiment natin. No? We want the alternative hypothesis to be true. We want our assertion to be true. Yun naman yung goal natin when we do experiments. So wala namang pumapasok sa experiments such that sana H0 yung makuha ko. Okay? Usually, gusto natin na ma-prove yung assertion natin, no? Which is HA. Okay? So that's why reducing the error gives us, in fact, a better opportunity na makapasok sa critical region and giving us a kumbaga favorable na conclusion, no? In terms of kumbaga parang experimentation reasons, no? Parang ganun. Okay? Although some may argue na wala kang paki dapat sa conclusion, no? Because if you are truly an unbiased na experimenter, whether H0 or HA yung makuha mo, it doesn't really matter kasi yun naman yung goal ng experimentation. It's supposed to be unbiased, no? Pero siyempre as engineers, we want to we want to test our assertions if they are correct, and kahit unbiased yung experiments natin, there is certain na results na parang favorable sa atin. No? Okay? Pero yun, medyo ano na yun, no? Parang mga, how should I say it? Parang medyo trivial na siya, pero for the purist, yung mga statistical purist, it's also important. No? Pero for us, not so much siguro. Okay? So, degrees of freedom natin is just the number of levels ng source natin minus 1. So in this case, machines, that's 4 minus 1. So levels is 3. Operators, we have 6 operators. Minus 1 gives us 5 degrees of freedom. And total natin is, yung total count natin is equal to this one. Minus 1. So that's 29. Tapos gawin natin is, again, ito lang yung gusto kong, ito yung ginagawa ko, no? Instead of calculating for the error, which in this case would be, wait lang, compute natin siya by deducting C18, which is this one total minus operator minus treatment. So gives us 27, no? And the way we calculate for, if we want to calculate it, no? Ay, wait lang. Sorry. Kaya pala. Dapat ito lang siya, no? May nabilang ba ako? Wait. Count. 6. Ba't 23 lang to? 6 times 4. Tama nga. Oh, kaya pala. Na-double minus ko siya. Okay. Okay, so kaya 15 siya. Okay? So, error can also be calculated dito as just the n minus yung degrees of freedom ni machine multiplied by degrees of freedom ng operator. Okay? So, kaya siya 3 times 5 is equal to 15. Pero, again, para sa akin, it's always easier to just compute the error by just deducting yung total minus yung ano, no, degrees of freedom ng mga sources natin. Okay? So, MS is equal to ito divided by itong value na to. And hindi actually natin i-count yung MS ni blocks, no? Kasi hindi naman natin ina-analyze si blocks. Then blocks is not a factor. It's just there to reduce variability. So ang goal lang talaga ng blocks, again, I'll reiterate this, no, is just to reduce this value, no? Itong 23 na to. So it was 65, now it's 23. Yun lang yung goal natin. Okay? So now that we're done with blocks, no? Hindi natin kailangan i-compute yung MS na hindi rin natin kailangan i-compute yung F-count niya. Okay, so to compute MS, MS of the machines divided by MSE or the MS error gives us 3.3. If you want to compute for P value, that's F dot this dot RT nito. Degrees of freedom 1 is 3. Degrees of freedom 2 is 15. Okay. Gives us 0.0479. So that's very close, no? So we would expect na F-crit will also be close to F-cut, no? Kasi close to 0.05 to eh. And 0.05 nga ba yung 0.05 naman. Okay, so F-crit is equal to F F dot inf dot RT. Probability natin is 0.05. Degrees of freedom is 3, 15. Okay, gives us 3.28 and it's very close now. Okay, so conclusion natin, since P is less than alpha, also, and F-cap is greater than F-crit, then we reject H0. Okay, so yun yung magiging conclusion natin. So pwedeng, therefore, ano nga ulit yun? The different machines have different, or bang pwede natin sabihin dito. Pwedeng, you can state this in many ways, no? Pero the simplest way you can state this is the different machines are significantly different in terms of product assembly time or rate. Let's just say time. Pwede ganyan. Or pwede rin the type of machine affects the product assembly time. Significantly affects the product time. Pwede din ganun. No? So, sige, ganun na lang. Parang big ko mas malinis pakinggan. The type machine significantly affects the product assembly time. Pwede ganun. Okay? So, the quick way, you probably want to know the quick way, no? Quick way to do this is, we imagine as if, kasi again, I mentioned na si RCBD, no? Yung randomized complete block design is, the calculations is actually similar to two-way ANOVA. Therefore, pwede actually gamitin natin is yung data analysis toolpack. Again, data analysis tayo. Tapos, ang pipiliin natin is two-factor without replication. Ito. So, let's do two-factor without replication. Tapos, input natin yung range. And isama natin yung labels. So, we have labels. Tapos, 0.05. Output natin yung range somewhere dito na lang. Yan. And if you press OK, you get this, no? So, delete ko lang to para umangat siya. Shift cells up. Delete. Shift cells up. Okay. So, compare natin with our results, no? So, you have, ito yung summary lang, yung M1, M2. So, kaya gusto ko ng labels class, no? Kasi parang nakikita ko tong, kumbaga, yung sa summary ko, mas nagme-make sense, no? Or mas readily visible kung saan galing yung data. Okay? So ito, rows, yung rows natin is actually sila yung machine. This machine. Columns natin is the blocks. Okay? So gawin ko lang blocks, machine, tapos error to total. Okay? You'll notice na same lang yung values na nakuha ko. Okay? So you see 15, 42, 15, 42, 23, etc. Pero ang difference lang is nag-compute siya ng itong values na to, no? Pero again, this is not a second factor, so delete na lang natin para so that we won't be tempted to say na second factor siya. Okay? So, again, kung gusto nyo, you can add conclusion dito, no? Conclusion, and kung OC kayo, you can copy the format, no? Para, yan, para okay tingnan. So, conclusion natin is, we can have the same conclusion, no? And if you notice, we have the same values as well. Yung p-value natin is 0.0479, f-calc is 3.33878, f-crit 3.28738. And therefore, we can make the same conclusions, no? Okay? So, okay. So, again, block design, similar to ANOVA, two-way ANOVA. Calculations are the same. Difference is, hindi natin tinitreat ang blocks as if it were factors, no? So, it's specifically just there para ma-reduce yung error natin. And therefore, dapat wala kayong values dito. If nilagyan nyo ng values yung blocks, no, when it's supposed to be a complete block design, then we will treat it as if you did a two-way ANOVA, and therefore if it were an exam, meron siyang appropriate na deductions, no? Okay? Kasi parang it tells us na hindi nyo masyadong na gets yung difference between blocks and two-way ANOVA. So if you do the quick method, always remove these values, no, if it's not a factor, no. Tapos dapat wala kayong conclusion about it because it's a block, no, again. Okay? So, I think we can end with that, no? But before we end, are there any questions? Okay ba tayo? May ano ba? Confusing portion sa lecture? Both the short method, itong long method and the short method are actually easy to do. Tama? Ito naman, medyo madali lang naman if you get the hang of the sum of square formula, no? It always has the same form. Hindi naman nagbabago yun. Kaya feel ko, if you get the hang of it, kahit mag three factors pa man tayo, feel ko makukuha nyo pa rin siya. Okay? Tapos ito, ang kailangan talaga i-put into heart nyo tong ANOVA table class, no? Always, this is always the form, no? Source, SS, DF, MS, FCalc, tapos p-value, f-crit, and conclusion. Okay? Questions? I think mukhang wala ng questions. None from Anjali. Thank you. How about the others? Russell also, okay na siya. Nag-thumbs up. Okay, that's good. Thank you everyone for the feedback, and I appreciate you coming in today, no, kahit may ongoing exam kayo. And I wish you good luck sa exams nyo, lalo na kasi nag-exam kayo sa MMME14, exam din sa ES1. I hope you can perform well sa mga exams. And I'll see you next week. Okay? Okay. Thank you.